It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmers Union Nice Coffee.
Hi guys, welcome to the very last video that I'll be doing for this topic on topic 4. So this is going to be all about recycling. This will be a really short one because there's not much you need to look at in this topic, but it really sort of brings together everything we've just looked at in terms of polymers. So as we talked about, there are some polymers that can be recycled, so they are thermoplastic polymers, and then there are some that can't be recycled, which are thermoset polymers. So what we're going to be talking about here is just the thermoplastic polymers. I'm just going to move this over so you can have a look. So if you've ever had a look on a plastic container or bottle, if you've got a drink or something there, maybe hopefully an iced coffee stubby or something like that with you right now, have a look at it and see if you can see one of these little symbols on the bottle, and that tells you what plastic it refers to. So polyethylene terephthalate, PET, is used in drink bottles. High density polyethylene and low density polyethylene we talked about in the last video, same as PVC. Polypropylene is another one, polystyrene, and then they've got this other one because there was a whole bunch of stuff they couldn't work out where to put in the category, so just called it other. So when they recycle plastics, what they do is they look at this number and they separate them into these categories, and then they can melt these down and reform into other shapes. Okay. It's really useful and good to recycle, because when we do that, it means we reduce the need to mine new materials. That reduces pollution, energy wastage, landfill, which is really useful. And the reason, obviously, we try to do all of this is that our population continues to grow, but the resources we have on the earth here doesn't. Okay, we continue to diminish them. We only have a limited amount of petrochemical stocks to make plastics, so the more that we can recycle, the better. So as we said, the difficulties in recycle come from the fact that we have thermoplastic and thermoset polymers. So thermoplastic polymers can be melted down to make into new things, whereas thermoset polymers, once we shape them, we cannot make new things out of them. They just burn or char. So it's really important you know what sort of plastic you have, and you design, hopefully, the recycling in mind when you are creating a plastic. Composite materials are something that we're starting to develop a lot more in response to the shortage that we have in plastics or in the petrochemical stocks to make plastics. So a composite material is something that's made up of two or more different materials with the goal or the aim that we get the properties of both coming together. So composite materials are nothing new. People in the Bronze Age, way back thousands of years ago, knew this. They knew that if they took a couple of different metals on their own, the metals had different properties. When they combined them, they got a much stronger metal. So they combined copper and tin together, which are both reasonably soft metals. When they combined them together, they got a much harder metal called bronze, which made a big difference in terms of their fighting weaponry and their tools for everyday life. So a similar sort of process here. What we're doing is taking two materials with different properties and combining them together. Generally what we try to do is combine something that's lightweight with something that's really tough and strong, and so that we can get something that's lightweight but really resistant to strong impacts. So a really good example is Kevlar armor, which you can see here was one of the first real major composite materials that was produced and mass produced, I guess, in a sense. So what actually happens for a composite material is you have normally your really strong fiber. Okay, so it's got high strength, high stiffness, low density. Okay, so what that means is it's still lightweight. Okay, but it's got a really high strength, really high stiffness. So this is almost like a really strong metal bar. And then what you've got is your matrix, all right, which has really low density and what's called good shear properties. So what that means is you can kind of cut it and mold it into a different shape of what you want. So you put these fibers or filaments within your matrix, and you get this sort of thing here, which if you just had the matrix, the sort of light material by itself, okay, you could mold it into a shape, but it wouldn't be very strong. If you had these fibers by themselves, it would be really strong, but you couldn't mold it into the shape that you want. So you combine the two together, and you get this really good composite material, which you can mold into different shapes, like you can see here. So if you've ever broken your arm or anything like that, you know, you get this sort of like fiberglass material. That's a good sort of example of it. Okay. Now, one of the downsides of making composite materials, which is good because you can get something that is light but strong, and it doesn't rely upon necessarily petrochemical stocks is that once you combine two different materials, it makes it really hard to recycle. So here's a good example of a composite material over on the side here. So this is just a packaging envelope. You see you've got plastic bubble wrap through here, which is one type of plastic, and then you've got another sort of plastic / paper material on the outside, which is a different sort. They both have different melting points, they both react differently to chemicals, so it makes it really, really hard to actually recycle these. So there is a high cost currently associated with these, because mostly what you need to do is spend a lot of time firstly chopping it up or grinding it to separate all the parts. Then you need to melt the different components, which requires heat, or you need to dissolve them in chemicals, which is also expensive. So while there's lots of benefits in producing composite materials, the actual recycling of them can be quite difficult. So that brings us to the end of topic 4. Hopefully you guys have been able to follow this pretty well. Just want to encourage you, look over the videos. Please, if you feel there's anything I need to explain more, you'd like more videos on, please make sure you leave a comment below. As always though, if you've got any questions, just ask and drink lots of iced coffee. It'll help you through Year 12.